Okay. Differentiate. Points of inflections become stationary. So that's a point of inflection right there, becomes stationary there or there. Stationary becomes intercepts. Intercepts there and there. And then start. It starts at the top left. We start at the bottom left. That is your second derivative of the maroon colored curve, which you don't have yet. But essentially it's your first derivative of the black curve that we have now. That makes sense? We just differentiate it. Now we're going to integrate. Any questions, Aya?
No, I think you
Like I said, this week's homework is on that.
Yeah.
And you can just make them up like I am. You know what I mean? You don't need more really, you just need to make them up and then you just take a picture of it and send it to me and I'll show you, I'll say if it's right or wrong. Let's do the maroon, let's integrate. We know how many solutions it should have. It should have 4 solutions this time. Because like you're integrating, you're going one higher. This one had 2 turning points, the black one. So our maroon one needs to have 3 turning points, and so on. Right? We know what needs to happen. Let's just make sure it happens. Intercepts become stationary. So intercept becomes stationary. Intercepts become stationary. Intercepts become stationary. Stationary points become points of inflection. So somewhere here, somewhere within these stationary points, there should be a point of inflection, which makes sense because I have to connect this stationary point to this stationary point, or this stationary point to this stationary point. So we kind of get that, and I think I'm just going to get started. The black curve, you start at the bottom again. So we start at the bottom, so it's not going to be, sorry, let's start at somewhere here. We're going to go up, it's going to be a stationary point, go down. There's my point of inflection and my stationary point here. See how it's changing concavity? This was sad. Now I'm going to make it happy. Can you see that? I'll do it again. Happy. And then again, at my stationary point, it should be a point of inflection. So look, happy, happy, happy. But then eventually it's going to change to a sad. And then look how many intercepts it's got. 1, 2, 3, 4. It's got 3 turning points. 1, 2, 3. Done? Easy? What's the only one you guys have to remember? What's the one I said that's really important? You've got to not forget. Horizontal points of inflections. You've got to not forget what happens with them. So, if it was a horizontal point of inflection, it's not just a stationary point, it's also an intercept, which means it's a stationary point on the x-axis. So it would bounce. That's all you got to remember with the horizontal points of inflections. All right. Yep. Good. So you want to do one more? Let's do the horizontal point of inflection one as well. There you go. That's a simple one, isn't it? Does it look familiar? Who is it? What is it? It's your y equals x cubed. So let's just make that into f of x. Let's integrate this, and we're going to differentiate this. We're going to try to do both. I'm going to integrate, and because you know it's x cubed, you already know what the integral of that is, and you already know what the derivative of that is. Here we go. If I was to integrate, integral ISP, we're going down for integration. Intercepts become stationary. Stationary points become points of inflections. So this stationary point becomes a point of inflection, but it's not stationary, it's a point of inflection. So it's more of a intercept than it is a stationary point. Okay, but because you know it's a horizontal point of inflection, no, I'm mixing it up. What am I doing? Intercepts become stationary. Stationary points become points of inflections. So they are, I wonder, so I know the answer obviously. We know it should just be a parabola, right? My only question to myself right now is, how come I can't go down? I'm just thinking, why can't I go down? And that's because of, how do you know? How would I have known? Interesting. I'm missing something. Let me get back to that and think about it again. I chose a tricky one for my own self. But it's okay. F dash, we know we're going to go up. F dash, we know we're going to go up, which means points of inflections become stationary, again. And we know stationary points, which are these horizontal points of inflections, become intercepts. So they're specifically going to be doing this or this. And then instead of starting at the bottom left, we're going to start at the top left. Now the thing is, the integral should have been the same. But my only question is, how would you have known specifically to do it at that point if it wasn't an x cubed? What other functions do I have that are there? Can they be negative? I guess because it's not in air, it's not in mid-air, that's all, because that's plus 0. If it was shifted down, and I was going to integrate, so if it was x cubed plus x, if I was going to integrate, I would have got this. Yeah, then it would have been allowed to go down. Fair enough. With that one, integrating that, only because it's such a basic one, it's not just going to be obviously a stationary point anywhere, it's a stationary point back to the same thing. So the derivative and the integrals at the same spot. The only thing is x to the power of 4 is obviously a lot faster, but otherwise you wouldn't tell the difference between the two. So I chose a bad one. I'll do another one. So it's the same answer, but I'll do it again. I'll do a different one. Let's go with something like this. This should give us a better response. Actually, I have a question ready for you guys. Question 9s and 10s from trial papers, which means the last ones. Here. You guys are going to answer these four. The sketch below shows a graph of y equals f dash, which is the derivative of the function y equals fx. And then I give the x values of all the turning points of y equals f of x. Double I give the local maximum points of inflection of f of x. So it's up to you. You've got two options you could do here. You can either integrate this and get f of x, or you just understand what it's doing with the f dash. So how would you find turning points usually? What does that mean to you now? What does turning points mean? What do you do? Y dash equal to 0. If this is y dash, when is it equal to 0? If this is y dash. Yeah. So everybody starts going, oh, turning points, that must be this and this, right? No, this is not f of x, this is f dash. So y dash is 0 at 2, 0, and negative 2. So x is negative 2, 0, and 2. Good job. Otherwise, this is the other method, right? ISP. We're going down, so we're integrating. Intercepts become stationary, 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 and then starts at the top left. I think you guys can probably even see the outline. But there it is. All good? And then from that, you can straight away tell turning points are here, here, and here. Give the x values of the local maxima on the curve. What's the x value of the local maximum on the curve? Local maxima. Yeah, but give the x value. Straight away by just looking at that. -1. Yeah, you looked at the y dash graph. I just drew the graph. Okay. All right.
I'm waiting.
All right. Relax. A little bit more work on this, right? Okay. Give the x value of the local maximum. The maximum is right here. That's the local maximum. When does that occur? At 0. I just drew it very bad, but you guys get it.
Oh, okay.
Yeah. Like you should know that was the stationary, that was the, what am I doing? Intercepts. That was the intercept became a stationary point. So x equals 0. That's where the local maximum is. Local means, so there's two words. You've got local and you've got global. Global is all of the maximums. Local is localized. So like, see? Okay, let's call this graph. How many minimums do I have? 3 minimums. But which one's the local? I don't like using local. I like using global and absolute, but that's all right. Which one's the local minimum? Say again? No. All 3. So the local minimum is localized. All 3. The absolute or global minimum is the absolute minimum. I like using that word. So the absolute minimum would be the smallest minimum that you'll have, which is the last one. Does that make sense? So in this case, if you ask for the global or absolute max, what's the absolute maximum for the first one that we were doing? What's the absolute maximum of f of x? It just goes on forever. What's the absolute maximum? Infinity. That's why your graphs for your homework, I gave you a minimum value. I said, well, find the minimum y value, but they need to be a domain. Otherwise, what would be the minimum value? Negative infinity now, because that's going down forever. Does that make sense? Otherwise, I have to stop it. If there's no stoppage, then you would say negative infinity. But in this case, the local maximum would be at a localized point, at a specific point, like that. Your absolute is the absolute maximum minimum. Sorry?
I can't.
You can't. That's just how they work.
Which one? I didn't hear.
I think the only thing you can do is connect it to your earphones or something like that. Yeah, that's like the best thing I can think of.
I don't know USB-C because.
I do.
Yeah, sure.
Yeah.
All right. Give the x values of any points of inflections. Obviously, again, what's the points of inflections on this curve? Well, let's think of it if we didn't have the Morone curve. When would points of inflections occur? When do points of inflections occur? Y double dash equals to 0, which means for the black curve, it would be where y dash equals 0 of that. Does that make sense? Because that would be the second derivative technically. When does y dash equal to 0? Y dash equals to 0 right here and right here. True? But isn't that also my point? Can you see that's my point of inflection on this curve? So x equals -1 and x equals to +1. It depends on how you see it. Me, honestly, feels me in my exam, I would have drawn the maroon color, maroon curve. Reason why I would have done that, because I'm very strong with ISP, so I would have done that. I wouldn't have not really gone through it more theoretically, which is what they wanted you to do. Give a possible sketch of the second derivative. Well, that's very easy now. Second derivative, we're going to go up, differentiate. Points of inflections right there become stationary. And then stationary points become intercepts. Start at here, and voila. An orange curve.
You do it based off of the original.
Of the original, correct.
Usually,
Because you're differentiating again. It's already y dash, yeah. So you're going to go second derivative, you differentiate it again. Make sense?
I think maybe you're wrong.
Tell me.
One to two.
You don't, right? You don't. That's it. You can be anywhere. You don't. You can't. Unless you are given the curve. That's it. Or unless you were given it, like they just said, draw it, given y dash equals -5. Sorry, y equals -5 for y dash. The y value, the y-intercept is -5 for, get it. And you will actually have a question ready for that as well. You'll see one of those in a second. All right, cool. Can we move on? So our plan for today, like, as you guys said, we'll do one more lesson of this and then we'll move on. But I've pretty much got you ready with some questions and 9s and 10s. 9s and 10s being the last two questions of the HSC. So band 6 only, which is where you'll see max mins anyways. You won't see them anywhere else. So we'll just do a bunch of them. If you guys feel ready, then we'll move on. Oh, and you know, obviously, what else is in question 9s and 10s? This beautiful one. Loan repayment and superannuation. But anyways, move on. Hey, there's one. I actually think you guys can do this without much help from me. The only formula I'll give you is the volume of a cone, unless you guys know it, but I'll still give it to you. You guys know it? That's it. That's the only formula you need. I think the rest you guys can do. Go. 4 marks. Read from the top. If you want to talk to me about it, like you're doing a step and you want to check if it's right, just say it out loud. I'll tell you if you're going right. That first line on the top is useful. Or the second line, sorry, at the top, if you guys can see it. What's the first thing you write? The second sentence. Some of its base diameter and height is 60. So what would the base diameter be? You don't want to use D for diameter. What would you choose instead of diameter?
Radius.
Yep, so what radius? 2R. 2R plus equals 1. That's step 1. Agree? What did part I ask you to do? Find H in terms of R. I think you guys just did that. Just make H a subject. There we go. We've done I. Ready yet? The first one we've got is 2R plus H equals 60. H equals 60 take away to R. That was easy. Now do double I. Find the volume. What do you think you're going to do? Sub H. There's your three variables. Can you see that? 1, 2, 3. There was your 1, 2. You made 2. You made one of them the subject. Sub 1 into 3. 3 becomes 2. You can see it's happening. Exactly as I explained it, it's happening. Double I. Let me confirm when you've done that. Sub 2 into 1. Sub 2 into 1. No, not 60. Oh, sorry. Yep. I is H60. Yeah. That's what you're going to substitute for this H. That's it. Beautiful. And then just look at what you're trying to prove, and it should be done. Done? Fire? You got it out? You? Done? Done? Yeah, I'm saying done. Part 3, what do we do? Too long. Too long. No, too long. No, you do know. How do we do part 3? Too long. Again. One more time. One more time. Ready? How do we do part 3? Make it equal to? And then what do you have to do? It's too long. Too long. One more time. Too long. How do we do part 3? Make it equal to? Then? Wrong. Wrong. What do we always do? What have you always done? Yes. After step point, you have to make sure it's a maximum. Then you're done. Don't ever say you can't do that last bit. That's meant to be done regardless of how you attempt everything else. Regardless. Regardless. Yes. Yeah, of course. Step point in nature. That's all you've been doing this whole last 3 weeks. Literally, we've done nothing else. Alright, where are you up to? No, go. You know what to do. Don't read into it. You sure? Come on, differentiate. Come on. Come on, you can do it. Make it equal to 0. Why are you stuck? D. That's what you're trying to prove. What is this? What is all this mess? I don't know what that is. B equals 1/3 I R squared H. I don't understand what you're writing. Cube. This one's squared. Square, that's square, that's 2. So then 3 and 3 cancel that. Okay, so it becomes 2. And then that becomes 2. And this becomes 40. 40 pi r, take away, looks good. Come on, you know that this makes sense for radius. It must be wrong. Yeah. What should be r equals? R equal? I'm not doing that. Think about it like this. It equals to 0, so I'm moving the r over. R is going to be 25. That's it. Bang, bang. That's yours. R equals 20. How come you had 25? Give me a second. Why did you do it at 5? Oh yeah, that should have been at 5 degree factor. Good job. R equals 20. You found radius, but that means nothing. You've got to prove it's a maximum. What do you do after you've done your step point? Nature. Usually we found the point, right? We found r and whatever. You realize we don't need to do that with these questions because the question is saying find the radius. All right. Triple I. Maria, you're okay with double I? You got it out?
Yeah.
Yep. dv on dr equals 40 pi r minus 2 pi r squared. I think most of you guys I saw took out a 2 pi, and then you got 20, take away r. No, 2 pi r, yeah. 2 pi r equals 0, r is 0, r is 20, and then the max.
Where is going to be 0?
You just put a white dash table. Right? But if you're going to go one before it, I think
You don't need to mind this one.
but I'm going to do the second one instead.
Second derivative one.
Yeah, second derivative is better than y dash table. Easy questions. You'll do the y dash table when the second derivative is annoying.
How do you know you do 3 points?
Second derivative
Nature.
is annoying. So like it was already hard to get your first derivative. You don't want to go again. That's when that guy's nice. Okay, I'm going to do nature. Nature is 40 pi, take away 4 pi r, and then of course that gives you like negative 40 pi or something, which is less than 0, therefore it's a max. I'm done. Find the radius, which makes the volume maximum. Finish. I found the radius, and I showed it's a max. What's the problem? What'd you do? Yeah, y dash table. Okay, relax. Y, oh, y dash table. 2 methods. It's you. You pick. Did you get a max? Then you're fine. Do you want to do y dash table? 19, 21, 190, good. You stubbed it into y dash, should be good. Any questions? I saw something from the solutions. I don't think it was any of you. No. Different Andy actually did it. You can't just write positive and negative for that. It used to be accepted, it's no longer accepted. You have to actually write the number. The reason why, because we don't know if you have actually subbed it into y dash or y double dash, and you could have got a positive and negative number, you could have fluke to max. So we actually want to make sure you subbed it into the correct y dash. So we need to see the specific number. Sounds good? Easy 4 marks. Let's do one more. Okay, I'm not going to do that one. Right, let's just confirm. Is that okay? That was literally your homework. Right? Stat points, nature, point inflection, sketch the curve in that domain. 8 marks. So good. For question 9, second last question of the paper. Amazing. Just trial papers. I just compiled a whole bunch of question 9s and 10s from the old syllabus. That's why they're question 9s and 10s. Otherwise now you've got 10 multiple choice. So they're a bit different. But anyway, how do you know this is a max-min problem? That's the 2 things. 1, the fact that there was a picture or some sort of geometry. 2, I think this word here. I like how she scanned it quick. The class before, they're reading everywhere, they don't know where to look. Scan quickly, maximum. That word, you see that, you know it's a maximum. If you remember, this is HSC as well. I think one was what? A rectangle and a quarter of a circle. This was a semicircle. Same thing. Go. I don't think we need the top. We don't need Lisa. We just need that bit there. Let me know if you've got an answer for something or if you've written anything. This is H. What are you going to write for the opposite side? H, this down here is going to be 2R. I like it. And then what's the circumference going to be? Two pi r, then divided by 2, which eventually becomes pi r. I like it. So therefore, if it says the perimeter is to be 20 meters, then you know 2r plus 2h plus pi r equals 20. And then again, find h. Come on, too easy. Whoops, minus 2r minus pi r plus 20. That was really horrible. I forgot to do 20 minus those two. That doesn't matter. You guys will, I'm sure, write it a little bit neater. 10, take away r, take away pi r on 2. There you go, fix it back up.
Alright, and got this, divide by 2. Yeah, I R, and 2, yeah, good.
Done. That's h done. How do we find the area of this thing? What is the area equal to? 2rh plus pi r squared on 2, pi r squared on 2. Again, what are you going to do? Sub h into this. This time, come on, pay attention and don't get it wrong. Take your time with it, and then triple I think you guys know what you've got to do. Differentiate. I have the area out. Another, the area out.
Try to avoid making this hash. Try to make the game as well. Try to be very strict with that. To make it look really good. You can have a quick look. 2RH. That's minus 2. 20R. Wow, this is a mess. And I can 2. This should be just 28. What is all this?
So this is R.
What's this?
Minus.
It was a minus 2r squared minus 2 and 2 cancel r squared. So yes, it's perfect. Then stop. Then you go 20r, 20r minus 2r squared, 2r squared minus half r squared, or minus 1 plus half is minus half. So you just rewrite the answer. Two r squared, we want 2r squared, which is what you want. Yeah, this 2 and this 2 cancel as well. That's it. And minus 1 r squared plus half is minus half. That's it. You literally can rewrite the question out. Once you expand, technically you can just rewrite the question for the variable. T and dr equals 20 minus 4 pi, 4r minus pi r. Looks good. Make it equal to 0. Well, obviously, what letter are you solving for? So therefore, this is not a quadratic. You bring your constant to the other side, factorize your r, get it out. Let's do it. Looks good. I think we're close. It looks like you guys are more struggling with the algebra than the calculus.
But all right. Maria, did you get area out?
Pardon?
Did you get the area out? Did you get this?
Yeah,
Double I?
I'm working now on it.
Okay. Do you want help with it?
Yes, please.
So you understand how to get A here, firstly? What are you up to? Double I or triple A?
You keep glitching out, so I'm lost. Like my internet connection's not the best.
Fair enough. Are you at double I or triple I?
Double I.
Double I. Okay. So we found H is this. Do you agree with that?
Yeah.
So we're going to sub that H into this H now.
Okay.
And that would look like this. 2R, 10 take away R minus pi R onto plus pi R squared onto. That becomes 20R minus 2R squared. Then when you expand this, 2 and 2 cancels. You're left with minus pi R squared. And then you can see that's exactly the same as the top. 20R minus 2R squared minus 1 plus a half is negative half R squared. Do you agree with that? Minus 1 plus a half
Yeah.
is negative half. Yep, that's it. And now we're going to differentiate this. That's the next page. I'm differentiating.
And then it's just stat points in nature.
Say it again?
And then it's just stat points in nature.
Yeah, correct.
Okay.
So 20 minus 4R minus 2 times half is gone, minus pi R equals 0. I would, at this stage, bring my r's to one side because I know it's not a quadratic. Then I would factorize my r, and I'm done. R equals 20 on 4 plus pi. Then I would differentiate. Differentiate again, I get negative 4, negative pi, which we know this is always less than 0, which means it's a max. Now I would stop. Reread the question. Did I just want radius? No, the question said also find the area to the nearest meter. Because I just did it with the other guys, I know the area became 28. You guys will go and sub it back in. So just literally sub this into this to find the maximum area. Any questions? And I think you're going to sub it in as a decimal, so it's like 2.8 or whatever.
You said R.
Oh, yeah, why? Why do I sub R in? No. I sub R into area because the question says, hence give this area. That's all. If the question didn't say that, I would have stopped at R. So essentially you're finding your Y value, right? Can you see how that's your Y value now? You sub back in to find your Y value. Just confirm you do get 28. Sub R back into this. Happy? All good? Done? 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 Done. Next question. try that. Give a possible sketch. Your answer can be different to the person next door. So don't think you have to copy it or it has to be the same. Because it's give any possible sketch. The curve has the following defining features. When x is negative 5, 0, and 3. Alright, I'll hold Andy.
What?
20 r minus 2, minus 2r squared
Is area.
Review. What's up? Talk to me. Not much. It's all.
Tell me, what's the problem here?
Nothing.
This, right here. You're A, the question said find A, so you're going to put into, what's H? H is this, is it?
Yeah.
And you sub that into this,
Yeah.
so you found H first, is that what you're saying?
And I submitted.
And then, should give you 20x.
I don't know. I look at these two laughing and if you really are.
Well, so the reason being, because like, why would you do the extra step when this is already terms of life? That's all.
I do hard work that into.
Yeah, but why?
Work hard.
Alright. A curve has the following defining features. Negative 5, 0, and 3, dy dx equals 0. What does that mean? Y double dash is greater than 0. What does that mean? For x less than negative 2.5 and x greater than 1.5, fair enough, while for anything between. Oh, fair enough, I think this is okay. You have something?
Oh.
Let me try it. Let's see. X is negative 5, 0, and 3. It's a stationary point. Fair enough. It's a minimum for negative 2.5. So, wait, negative 2.5. So here. And greater than 1.5. 1.5. It's a minimum. And anything between, it's a maximum. Yeah, I got it. Yeah, look. So it's going to look like this, right? Stationary point. That's your point of inflection. That's a stationary point. That's a point of inflection. That's a stationary point. True? Let's make sure, but I just guessed that right now. Let's see. That's stationary. I think I'm happy with that. Is it a minimum for negative 2.5? Yes, it is. Is it a maximum between 2.5 and 1.5? Yes, it is. And then it's a minimum again. I'm happy. Done. Any questions?
How do you have to prove reduction?
Huh? I don't. Right? Hold on. I don't know, but it must be a point of inflection of 2.5. Why?
That's where it changes.
Yeah, right. It's telling you before this, it's a min. Between this, it's a max. So what about at that? It's a point of inflection.
Yeah.
Does that make sense? Before it, it's a min. Up between it, it's a max. So that means at that point, it must be a POI. Good. Next one. Thank you for the question. Look, you guys got a choice here. It's 7 o'clock. We do a really hard one, which would be the speed question again. And we'll look at another speed question. And if we're good with that, then we move on from max min, we'll start another topic. Or we don't, and we just continue. What do you want to do? Hard and see how we go. And if we feel like we can kind of wrap our head around it, then that's it. We just move on. And then the rest will be just, as we're doing homework questions and prelims and stuff, I'll keep introducing max min problems. So we're not going to run away from them. It just will be part of your homework rather than our classwork. Okay. Then the last one is that. Question 10, speed. What did I say is the hardest part of speed ones?
Yeah. You feel like this because you don't have answer.
Sounds good. That's how all speed questions are. No, not last week, week before, I think.
Yeah.
That's good. Well, that's how they all are. I can't change the questions. This one's exactly the same, you're right. What can I do? I think that was from James Roos, and this is from, I don't think this is from James Roos, but this could be from James Roos again. Yeah, same question. Doesn't matter anyways. What was the hardest bit? What was the hardest bit of speed questions? Part I. What's the hardest bit of loudness questions? Part double I. Just keep that in mind. Let's see. If you guys can do it, great. I'll give you guys a minute or two to think about it, maybe remember some things. You said we did it, so does that mean you guys can do it? I don't know. Isn't that what you mean by we've done it?
You said that.
So you done that.
Yeah.
We didn't retain anything.
Yeah, good.
Again.
Good.
I think
So
it's
I'm happy to do this for like 3 or 4 times a week, 3 or 4 times this term until you guys can actually spit it out. Because I'm worried if it is in your exam, there's not many people that have ever been able to execute them. So have a read, and I'll start it again as well. Everything's easier second time around, so hopefully a little bit better today. It's all about the rate, and I think the problem I had last time, if you remember it, was I said there has to be something per hour, I think, from memory, but anyways. Let me try to attack it a second time and see how we go this time out. 2 sailors are paid to bring a motor launch back to Sydney from Gilligan's Island, a distance of 1200. I think before we start now, we know we're going to use this, so let's just quickly draw it up. Distance, speed equals distance over time. So the distance is 1200. They are each paid $25 per hour for the time spent at sea. So that means the 2 sailors are paid $25 per hour for the time spent at speed, per hour, times 2, which means $50 per hour. Yeah, that's it. $50 per hour. Fair enough?
Yep.
The launch uses fuel at a rate of 20 plus V squared on 10 liters per hour. So R equals 20 plus V squared 10 liters per hour. Whoops. Per hour. Diesel costs $1.25 per litre. That means it's going to cost me 20 plus V squared on 10 litres, but also every litre is $1.25. So that means I'm going to multiply that by $1.25. So we agree with that so far? What's 20 times 1.25? 25? 25 plus, let's just write for now 1.25 V squared on 10 per hour. Does that make sense? Dollars? I don't even have it. These are costs. Like that's how many liters. Yeah. Dollars per hour. Dollars per hour. Yeah, which makes sense. That is dollars per hour. It makes sense. That's how much it costs to run. Yeah, it does actually make sense, does it? Yeah. So like this is, let's call it the wage of a human. This is the wage of a machine. So it kind of makes sense. Okay. We're all at the same rate, same space, same place. Good. Per hour, just so you guys can see it's the same pH. Good. So we changed the LH, which was annoying, to a pH. Okay, good, 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 good. Now, obviously we want to know, show that the blah, 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 total cost to the owner is this. So we know the total cost is technically 50 plus this amount per hour, but for how many hours are they going for? We know that because we know time is equal to distance over speed. We know the distance is 1200 over speed, which is v. So now I know that the total cost equals 50 times 1200 over v plus 25 plus 1.25 v squared over times, how much easier was this second time round? True? Imagine third time round, you'd be like, I really get this.
I didn't really count it 200.
But that was only the $50. Now this is the 25. Two different brackets. You get, yeah?
Yeah.
So 50 times 1200, 60,000.
That's the extra bracket.
Which extra bracket? This one here?
Yeah.
I just do that so I know, yeah. But remember I said this is the wages for the humans and this is wages for the machine?
Oh,
So like this is still per hour, it's how much it's costing per hour. So the total cost is this plus this times 1200 on B. I guess you could have done it as one big bracket, you could have just done 50 plus 25, which is 75. 75 times 1200. Maybe second time round I would have, third time round I would have done that. But I'm breaking it up for you guys. Doesn't matter, 25 times 12 is 30. 30,000 on V plus, and I'm just going to assume this becomes 150 V. Therefore, the answer is 90,000 on V. That wasn't too bad now. It's just the beginning. You saw that, how slowly I did. I said, okay, let's do it. $25 per hour. There's two of them. $50 per hour. Done. Then I said R is 20 liters per hour. Change that to per hour. The cost per hour. I changed it to cost per hour. I worked out how many hours, which is 1200 on V. Done. Yeah? Done? Do I need to differentiate this? Or can we say you're okay with that? We'll just start a new topic. How do we differentiate? What's the first? Let me just hear what I want to hear. Bring the V up. That's it. If you're going to say bring the V up, then I think we're okay. Done. Let's stop it there. You guys can finish it off.